already out of time, so I will just go through the program and show just a few examples. So the program is given certain theory. We start from theta 0 and compute the spectral network. And then we gradually increase pi. And for each theta, we can find a spectral network. And during this scan from 0 to pi, we find some finite S-walls. That means we find the BPS states for this theory. And the intersections between finite S-walls gives you the U1 charge of the BPS states. So we repeat the same theory for different moduli space. We could find at some time the number of BPS states jumps. So we say a wall crossing phenomenon. So for example, this is a simplest example, which is A1 compactified on D7 irregular puncture. And so here is an example of one spectral network. So when we change theta, the whole spectral network is rotates, and at a certain value, these two lines collide, and you see a right line here. And then at the other theta, these two lines collide, and you see another right line, finite line here. So in the end, we see that this theory has two BPS states. One corresponds to this cycle, the other one is this cycle. We can tune the parameter a little bit, and this will move the position of the branches, and then we say that basically the BPS states didn't change too much. It's still like here is one BPS state and the other one here. But if we change the parameter, if we separate these three branches too much, then we see suddenly, originally we have one BPS state here, one BPS state here. But if we change this too much, suddenly we create a new BPS state here. So when we tune the parameter, we go from 2 BPS states to 3 BPS states. That means we have a wall crossing. Yeah, here is a picture showing originally we have 2 BPS states, and here after wall crossing we got 3 BPS states. Yeah, so here is a summary of the finite S-walls and how this finite S-walls become from 2 becomes 3, and the states and their charges. So let me start with here is a compactification from A1, and here is another example compactified from A260 series. And the S-wall looks very different from the previous one. But in the end, we found that the original S-wall has this shape with 2 states, and after wall crossing, it has this kind of shape, but has 3 states, and the IR charges are the same. So if we compare this case and this case, we found that these 2 different constructions leads to the same BPS states and same wall crossing phenomenon. So we can there is a good chance that these 2 different constructions give the same IR fixed point. And so I don't have time to show all these results, but well, you can trust me. You can look at my paper that all these things gives us different constructions. They gave us according to the class they gave the same spectrum. So yeah, the conclusion is we have different classes of Argyres-Douglas theory from different construction, but some of them, although they look different in geometry, this Riemann surface geometry is also different, but they lead to the same IR fixed point. So we prove this, or we kind of find some evidence of this conjecture by looking at spectral network and check the equivalence of BPS spectrum and BPS states. So yeah, that's my talk. Sorry for the time. Any questions?
Okay, if there are no more questions, or if you have any, please ask the speaker later.